All right, today we're going to be talking about scatter plots and what's called the lines of best fit. So we're going to interpret some ideas about what a scatter plot is, which is just a bunch of graphs of points. And we're going to make a line of best fit and evaluate some predictions on that. So let's talk about different types of scatter plots. We have three different types. We have a positive correlation. This is where one thing gets bigger as the other one gets bigger. The more that you do this, the higher this becomes. Negative is the other way. As one gets higher, the other one gets lower. The more you practice your defense, the lower the other team's score. Okay. No correlation, things that have nothing to do with each other, like your shoe size with your math grade. So there's all these different types that you can have. A positive correlation, the more you study, the higher your grade on your test. The more you work on defense, the lower the other team's score. And all these different ones. Now, when it's no correlation, notice there's no line that's put through. This red line is called a line of best fit, and we are also used as a prediction equation. We're going to be making those today so that we can go ahead and kind of predict what could possibly happen. Let's look at a couple problems. All right, so here we have a graph, and the simple question is, what kind of correlation is this? Is this one that is a negative correlation, a positive correlation, or the dots are just kind of scattered all over the place? Well, this is most assuredly a negative correlation. Each year, the number of people sharing the computer goes down further and further because they probably get more computers. All right, let's try another one. This one, each year, we're going to get more and more prescriptions. So this is a positive correlation. Now, looking at some of these things, we can go ahead and even just look at a chart. As this one goes up, what's happening to the other one? It is going up also. So if they're both going up, that's a positive correlation. What would you expect for someone who's 5'6"? So that's in between these two. So you would expect it to be in between these two values. Maybe a little bit closer to the 60 than the 20. So maybe 159 or 152. There's some difficulty with this kind of problem. These numbers are a little too close together to know for sure without doing the math. And if they're just asking you to approximate, this should have been a little better question. But 152, 159 probably wouldn't have been too bad of an idea. These two were probably off because they were way too close to that 62. All right, so here's an equation of the year and how many millions of people there were. So this year, 5 million, 50 million, 100, 200, 1,000, 2,000, 4,000, so on and so forth. Well, we can go ahead and make a scatter plot. Basically, in other words, we're just graphing them. Boom, 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 boom. Now, we can go ahead and there's most assuredly a positive correlation. As we're going up, this is going up also. So we can go ahead and create a line. So we're going to draw a line of best fit. Now notice this dot down here is kind of way off. That's okay. We don't have to fit every dot in there. There are times that there's going to be dots that are outside. So we did this line of best fit here. And we drew it. It doesn't have to be a connected dots. We want a straight line. So here's our straight line here. Now we're going to use this to do a prediction equation. And what you need to notice is the two dots that are most on that line. So this one here and probably this one here. Those will be the two dots or the two ordered pairs I want to go ahead and use. So these are the two dots that we're going to go ahead and use because they were the ones that were on or closest to that line that we drew. Now that line is going to be probably a little different for anyone who draws this. Maybe you're going to use this point instead, these 2 points, and so it'll be a little bit off, and that's why it's a prediction and not an exact value. So we go ahead and we have those 2 points. Now we want to write an equation. Well, our equation again is y equals mx plus b. So we got to start with finding the m. It's an x and a y and an x and a y. So let's go ahead and find the slope. y2 minus y1, x2 minus x1. Subtract those out. You get a really big number. For these types of problems, since we're dealing with really big numbers, we can just go ahead and divide it and we get 35.1. We can go ahead and simplify them. Where you're doing real world examples, we can leave the decimals. That's fine. All right, once we have this one, we take one of the points and we can go ahead and use our formula, b equals y minus mx. Plug the point in, 1,000 minus 64,000, almost negative 63,935. And we can write that as our b value, and our slope was 35.1, and that's our equation. Now, I said that we can also use it as a prediction equation. Well, this is how we can use it. So predict what the value of the world is going to be in 2010. Obviously, we were past that. That's how old these books are, but we can go ahead and do that. And by putting 2010 in that value for x and just doing some multiplication. Multiply here and subtract for a value of 6,616. So again, that's by our chart, that's in the millions. So they wrote it actually out this way. All right, here's another one. Let's just try this again. So we have these points. These are our x values, and these are our y values. So we can go ahead and plot these points. This is a positive correlation. As one goes up, the other one goes up also. There are some jagged parts in it, but this is definitely a positive correlation. So now we need a line of best fit. This one's going the wrong way. This is a negative correlation. This is just, so that one can't be it. And we can't go ahead and play connect the dots. We have to have one straight line. So the only one that works is this b value. So with this b value, here's our line. So now let's look at the line. We have this point here at 4 and this point here at 10 that are closest to our line. So when I go ahead and do that, I want the point at 4 and the point at 10. Find my slope, which gives me 8. Put in my ordered pair. Again, I just chose the first one. And I get 1,104. Put that into my equation with the 8, and that's my equation. And then I can use that to predict in what's the value going to be in 2015. Well, just be careful because the original equation said since 1988. We had some very big numbers on the first one. This one just had these small numbers because it's years since 1988. So because of that, I have to be careful, and I have to subtract from 1988. So it's only 27 that I'm going to plug in, not 2015. So I plug in 27, 216, I get 1,320. That's what I have for you today.